Okay, so how do we actually sample a hydrothermal fluid and how do we understand its composition? So like any good scientist, I like to take duplicate samples with a device like this. This is called an isobaric gas tight sampler. It's measuring the temperature of this smoker. It's also collecting about 150 milliliters of sample that I will do my analysis with. I would take two separate ones of these and then I actually try to understand and calculate, which is what I'm going to show you now, what we call the end-member hydrothermal fluid composition. So whenever you've got a hydrothermal fluid coming out from seawater, from the crust into seawater, you essentially have a mixing process going on. And so I'm going to draw a little XY plot here. And I'm going to put HT here. This is our hydrothermal end of the scale. And I'm going to put SW here. This is our seawater end of the scale. So what you're looking at in this picture is a mixing process. And if you want to use an analogy, you can think of this as like coffee and milk. So at this end, it's pure coffee, black, no milk. This is nothing but milk. Everything in between is everybody's taste in coffee, whether you want a little bit of milk in it or you want something very milky like a latte. What you will actually get is a mixing line. So we're going to have seawater here and then our pure hydrothermal fluid over here. And this can be, so let's pick an element, for example, let's pick calcium. So this is our calcium concentration on the y-axis. Give it some units. So if I want to know what my hydrothermal fluid is and how I do this, well, first thing I need to know is I need to know what seawater is. It's pretty easy to collect that and measure it. I'm going to try to take some samples of hydrothermal fluid. Now, if I'm lucky, I'll get my data points showing up over here. And then I will draw a simple line, what we call a mixing line, between seawater and something that hits the y-axis here. And what we actually do to make a scale here is we use magnesium concentration. As I told you earlier, magnesium is completely removed from hydrothermal fluids, so a pure black smoker has almost zero magnesium in it, whereas seawater has our wonderful 53 millimolar. So this gives us a nice scale of mixing. So what I will do is I will take samples, and this is a beautiful sample. It was very, very pure. It had very, very low magnesium, but sometimes the pilots have some difficulty. Sometimes the vent is not very cooperative, and I will get samples that are here or here, and things start to get very, very complicated in that case. Thankfully, if you measure your magnesium concentration, you know where you are in this X space, and if you do it enough times, you create a mixing line that you can then extrapolate to find the end member. And this is a line that you've seen before in school at some point. Y equals mx plus c. Your y number is equal to the slope times your x number plus the intercept. This intercept c, that is basically our hydrothermal end member. The slope we don't need. The slope is not so important. But we give this equation some x's and some y's with our measurements of magnesium and calcium, and then we calculate C. And that's actually how we calculate a hydrothermal end member. So you guys